Learning Goals. Welcome to this learning session on understanding chemical formulae and ions. In this course, we shall address fundamentals of chemical formulae, interpreting molecular formulae, understanding ions and their types, writing and balancing ionic formulae, complex formulae and practice. There will be a quiz at the end to test your knowledge.
Introduction to chemical formulae. Chemical formulae are a concise way to represent the elements and the number of atoms of each element that make up a compound or molecule. They serve as a universal language in chemistry, allowing scientists worldwide to communicate complex chemical information efficiently. Understanding these formulae is fundamental to comprehending chemical reactions and properties. These symbolic representations are crucial for predicting how substances will react and for calculating quantities in chemical processes. For instance, knowing the formula for water, H2O, immediately tells us it contains hydrogen and oxygen atoms in a specific ratio, which is vital for understanding its behavior. Elements, the building blocks of matter. An element is a pure substance made from atoms that all have the same number of protons in their nucleus. This unique proton count, known as the atomic number, defines each element and gives it distinct chemical properties. There are currently 118 known elements, with 94 occurring naturally on Earth. Each element is represented by its own chemical symbol, which consists of one or two letters. The first letter is always capitalized, and any subsequent letters are lowercase. For example, mercury is represented by Hg, derived from its Latin name hydrargyrum, meaning water silver. Atoms and molecules defined. An atom is the smallest particle of an element that still retains the chemical properties of that element. It is the fundamental unit of matter, composed of a nucleus containing protons and neutrons, surrounded by electrons. For example, a single atom of oxygen still behaves as oxygen. A molecule, on the other hand, consists of two or more atoms chemically joined together. These atoms can be of the same element, forming a molecular element like O2, oxygen gas, or different elements, forming a compound like H2O, water. Many elements that are gases at room temperature, such as hydrogen, H2, nitrogen, N2, and chlorine, Cl2, naturally exist as diatomic molecules.
Compounds, elements chemically joined. A compound is a substance formed when two or more different elements are chemically joined together in a fixed ratio. Unlike mixtures, compounds have unique properties that are distinct from the properties of their constituent elements. For example, hydrogen and oxygen are gases, but when they combine to form water, it is a liquid.
The chemical formula for methane is CH4. This formula indicates that each methane molecule consists of one carbon atom, the one is implied when no subscript is present, and 4 hydrogen atoms. In total, there are 5 atoms in one methane molecule. Compounds are not found on the periodic table, only elements are listed there. The rules for writing chemical symbols are strict to ensure clarity and avoid confusion. Every element has a unique symbol. A chemical symbol is either a single capital letter or a capital letter followed by one lowercase letter. This convention is essential for accurately representing chemical substances. Many symbols are derived from the element's English name, such as O for oxygen or C for carbon. However, some symbols come from Latin or Greek names, like Fe for iron, from ferrum, or Na for sodium, from natrium. This historical naming reflects the early discoveries and linguistic influences in chemistry. Molecular formula interpretation. Molecular formulae provide a precise count of each type of atom present in a single molecule of a compound. The subscript number following an element's symbol indicates how many atoms of that element are in the molecule. If no subscript is present, it implies there is only one atom of that element. For example, in the formula C6812O6 for glucose, the 6 after C means 6 carbon atoms, 12 after H means 12 hydrogen atoms, and 6 after O means 6 oxygen atoms. This detailed information is crucial for understanding the composition and structure of complex organic molecules, which can have many atoms. Introduction to ions. An ion is an atom or group of atoms that has gained or lost one or more electrons, resulting in a net electrical charge. This process of electron transfer is fundamental to chemical bonding and the formation of ionic compounds. Atoms form ions to achieve a more stable electron configuration, typically a full outer electron shell, similar to noble gases. When an atom loses electrons, it forms a positive ion called a cation. Conversely, when an atom gains electrons, it forms a negative ion known as an anion. The charge of an ion is indicated by a superscript at the top right of its chemical symbol, such as Na+ for a sodium ion or Cl for a chloride ion. Cations and anions, metal versus non-metal. Metal atoms typically lose electrons to form positive ions, cations. This is because metals generally have few valence electrons, which they readily give up to achieve a stable electron configuration. For example, sodium, Na, an alkali metal, loses one electron to become Na+. Non-metal atoms, conversely, tend to gain electrons to form negative ions, anions. Non-metals usually have many valence electrons and gain more to complete their outer shell. Chlorine, Cl, a halogen, gains one electron to become Cl. These oppositely charged ions are then attracted to each other, forming ionic bonds. Polyatomic ions, groups of charged atoms. A polyatomic ion is a charged species composed of two or more atoms covalently bonded together, acting as a single unit. These ions are crucial in many chemical reactions and are often found in common compounds. Unlike monatomic ions, which are single atoms with a charge, polyatomic ions involve a group of atoms. A common example is the sulfate ion, represented as SO4 ". This formula indicates that one sulfur atom is chemically bonded to 4 oxygen atoms, and the entire group carries a net charge of -2. Other important polyamic ions include NO3-, carbonate CO3-2-, and ammonium NH4+, each with a distinct structure and charge. Writing ionic formula, balancing charges. When writing the chemical formula for an ionic compound, the goal is to achieve electrical neutrality. The total positive charge from the cations must balance the total negative charge from the anions. This principle ensures that the compound as a whole has no net charge. The criss-cross method is a useful technique for determining the correct subscripts. For example, in sodium sulfate, a sodium ion, Na+, has a single positive charge, while a sulfate ion, SO4 has 2 negative charges. To balance these, 2 sodium ions are needed for every 1 sulfate ion, resulting in the formula Na2SO4. The subscript 2 for sodium indicates 2 Na+ ions, balancing the 2 charge of the sulfate ion. Interpreting complex formulae with brackets. When a polyatomic ion is present more than once in a chemical formula, it is enclosed in brackets, and a subscript is placed outside the brackets to indicate the number of those polyatomic ions. This notation is crucial for accurately counting the total number of each type of atom in the compound. Without brackets, the subscript would only apply to the atom immediately preceding it. Consider the formula for magnesium hydroxide, MgOH2. This indicates 1 magnesium atom and 2 hydroxide ions, OH-. Because the hydroxide ion is a polyatomic ion, the subscript 2 outside the brackets means there are 2 oxygen atoms and 2 hydrogen atoms in total within the molecule. This is a common source of error if brackets are not correctly interpreted. Formulae practice and review. Mastering chemical formulae requires consistent practice in both interpreting existing formulae and writing new ones. Reviewing the rules for elements, atoms, molecules, compounds, and ions will solidify your understanding. Pay close attention to subscripts, superscripts, and the use of brackets for polyatomic ions. The ability to correctly interpret and write chemical formula is a foundational skill for all areas of chemistry, from understanding basic reactions to performing complex stoichiometric calculations. Continued practice with various examples will build confidence and accuracy in this essential area.
Summary. Well done. You have completed the course Understanding Chemical Formulae and Ions. You should now be familiar with Fundamentals of Chemical Formulae, Interpreting Molecular Formulae, Understanding Ions and their Types, Writing and Balancing Ionic Formulae, Complex Formulae, and Practice. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.